Calculus, we're going on to vectors. If you remember, we went through there. The next 3 units are on vectors. Then we'll be having our midterm. You might have noticed I've written on the board test number 2 and choice number 2. Doctor, please. Is on March 7th, which is not this Tuesday, but the Tuesday after. This is only a very tiny unit. That's all it will be. Yeah.
So when are you going to give us our choices?
So it'll probably be Thursday again, like I did before. So like Thursday, the whatever day that would be. 4th or 3rd or whatever. Okay. So this unit won't be bad. If you've taken physics, we're talking about vectors. So we get into 3-dimensional vectors, so which they don't do in physics. So math, of course, is better than physics, right? So that's why we do 3 dimensions. I know. So I shouldn't say we're all part of the same mathematical community. So here we go, February 24th, 2017. Now I'm going to, hold on a sec, we'll do this one as a class. Because I know some people forgot this over the last 2 years. Okay, now I wrote on there, can I please do this, guys? Okay. Here's my triangle. I have one main weakness as a math teacher, and that's that I can't draw triangles that well. So please don't go by the scale. Okay, no, none of my diagrams will ever be to scale, ever. Please go by the dimensions. I'm not expecting you to do it by scale. You may on your test solve things by scale if you want to, but assume that the diagrams are not the scale that I draw, okay? Secondly, in here, I gave you a hint. I said to the nearest tenth of a degree. In this unit for vectors, you may use degrees for everything, and I encourage you to, okay? Because that's what I'll be doing all the answers will be in. Only in the calculus we'll be using radians for, okay? Does anyone remember how to solve this back from grade 10? Yeah, go ahead, Helen. Cosine law. Can you recite that from memory, please? Go ahead. Very good. Now, before I continue, why can I not use SOHCAHTOA on this? Can someone other than Haley tell me why I can't use SOHCAHTOA? Yeah, go ahead, Nathan. There's no right angles. Okay, so that's out. Why can't I use sine law? Because when I was a teenager, I loved sine law and I hated cosine law. Why is sine law out? Yes. You need an angle. You need at least one angle. So you need things that are opposite. If you take a look here, right, 16.5, there's nothing. 14, there's nothing. And 18, there's nothing. You need at least one set of opposites. Okay, can I get someone who's brave and tell me what angle you want to solve for first? It does not matter to me. Derek, go ahead. Top, left, or right? What should I solve first?
Let's solve for top.
Top. So I'm going to call this theta. Okay, I'll be using the Greek letters theta, beta, and omega, or alpha, or whatever it is. Okay, so if we're to, this is the key to these cosine law questions, and this should hopefully be reminding you guys back from grade 10. If that's theta, what's little c going to be? This is really important here. Yeah, go ahead. Yeah, no?
16.5.
How'd you get 16.5?
It's across from both.
Right on, okay? Little c is going to be your side, big C is going to be your angle, right? If you chose 18 because it's the biggest, you'd be solving for this angle, right? So I'll just sub that in here. So that says 16.5 squared equals 14 squared plus 18 squared minus 2, 14, 18 cos theta. And if you want to call it cos c, go ahead. I'm not picking on that. I just like Greek letters there. Is this starting to come back for some people a little bit? I hope. You guys did this last semester, I hope? No. Grade 11, you definitely did? Grade 10, you definitely did? Okay. Great, I want to isolate cosine. What's the first step I should do here, please? Somebody new, please. Yeah, go ahead, Billy. Yeah, I'm going to, and you can square that at the same time if you want to. I can't do that in my head. I'm letting you guys do that. Now, for someone other than Bailey, that's definitely correct. Why do I not move the 2, the 14, and the 18 over right now? Go ahead, Tori.
Because it's attached to the
Yes, that's from multiplying, right? Those things are added and subtracted. Can I get somebody to use their calculator? Sorry,
Why is 18 positive?
Because you know what I love about you guys? You don't raise your hand. You're like, I don't know anything. And all of a sudden, Mr. Sadler makes one small mistake, and it's like everyone's hand shoots up, and that's that. Okay, one small mistake. Thank you. Okay, can somebody please get out their calculator and calculate that for me? Go ahead, please.
272.25 minus.
Oh, keep on. 196.
196 minus 324
Okay, equals.
equals nothing.
Oh. 28 and 18.
504 cos theta.
And hopefully your calculator will do that. If you do not have a calculator, it's time to start bringing one. Okay, phones are not permitted to be used as calculators. It's okay today if you don't have a calculator, but starting Monday, bring a calculator, okay, for the next few months. Okay, can somebody do the left-hand calculations for me, please? Yeah, go ahead.
I got negative 247.
Now, I can know who's sitting in the back, if you don't mind me embarrassing you in front of the whole class and saying, Mr. Sadler, can I skip 100 steps until I get to the answer? And the answer is yes. Okay, right? As far as what you would have to give me if this was a real trig question, you have to give me this, maybe something like this, you know what I mean? And then I'm okay for that, right? I'm just showing all my work because I'm a teacher, just a teacher's kid. Okay. Caleb, since you've been sitting so quietly at the back today, what's my next step to get isolate cos theta, please?
You like divide the negative 504 over.
You certainly do. I would strongly advise against typing that into your calculator unless you're Luke and you have a super duper calculator. I'd leave that as a fraction. What's the next step to get theta by itself? Oh, please play along with us. Yeah, right?
Do cos.
Yeah, cos inverse right here. So cos inverse of all of that. Okay, what do we got for an angle to one decimal, please? 60.6. Can someone confirm? No? Yep. I thought you said no. But deep voice, yes and no sounds the same. Okay, 60.6. Are we feeling sort of okay about that first angle?
Oh, that would explain a lot because I'm in grade units.
Now, if you want to use cosine law 3 times, you may, but I'm not going to. James, what is maybe a faster way to get the second angle off the top of your head? Do you know?
No.
Okay, that's okay. So I'm sorry, it's early in the morning. I didn't use the question. Go ahead, Gail. Yeah. So what angle would you like to find? Would you like to find the left or the right, please? Okay. Why can I finally use sine law?
Because you have an
Yeah, I have opposites, right? So I'm going to use this opposite to this, and this opposite to this. Okay, is what I'm going to use. Okay? So I'm going to write that as sine beta over 18 equals sine 60.6 over, what was it, 16.5? Is that right? Can someone confirm that for me? I think that's right. If you did it the opposite way and found the right-hand angle, you'll still get the same answer. Okay? Now, why I like sine laws? Look how long this took. Okay, for a conscientious math student like myself, you know, this would take me like a quarter of a page to do. This takes me this small amount of work to do. Can I get some brave soul that hasn't raised their hand today to tell me how to get sine beta by itself? It's one step. No, you guys all raise your hand. Nathan, go ahead. Yeah, so I'm going to multiply it by 18. So I'm going to say sine beta equals 18 times sine 60.6 divided by 16.5. Then I'm going to say beta equals sine inverse of all that. Okay, can someone be tremendously brave and try and give me an answer for that one? Alistair, I'm going to pick on you since I see you calculating it right now. Oh. You can calculate right now, it's okay. Just hold on. Okay, just so you guys know, I'm doing this not because I need practice in trig, it's because you guys need practice in trig, which means you guys need practice actually doing the calculation. So I'm not really picking on Alistair, I'm commending him for actually typing in these numbers yourself to do, because you guys should be able to get the same answer that I do. You know, does that make sense? Right? Well, last sec, Alistair's calculating away. Uh-oh, he wants to pass. Chris, go.
71.88 degrees.
I call that 71.9 because we're rounding one decimal, if you remember.
Wait, we have to do it?
You use 60.16.
Chris? You maybe missed this part. I didn't write on the plan, it was so many times. Somebody gets that, everyone else got 71.9 or something close to it? Yes? Okay, now there's a really, really fast way to get the third angle. What's the super duper fast way to get the third angle? Haley, you're all over trig, go ahead. Very good, okay. So I'm gonna call that, I don't know, omega, I don't know what this one is. Is this omega? That's the one I use. Is that omega?
Yep.
Okay, so I'm gonna say omega equals, well, that'd be an ohm, right? 180 minus 60.6 minus 71.9 degrees. 132.5, oh boy, 57.5, is that right? That's not right.
I got 47.
47.5. Okay. Hopefully that should be coming back to you. Now the reason you're saying, Mr. Sadler, we're calculoids, we're doing wasting our time back in grade 10. And and the reason for that is this whole unit is based on trigonometry. Like vectors, for those who have done physics, we're dealing a lot with angles and measurements and distances and all that stuff, right? So we'll be needing trigonometry, both cosine law, sine law, SOHCAHTOA, all that stuff. Again, we'll be doing identities. No, we're not doing any of that stuff here. We're just dealing with distances here. I'll hit pause on the video. You guys have a second to catch your breath. Thank you for the good work so far. And we'll